Hi, I am Karthik Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Hi, I'm Karthikeyan Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I'm Raghunendra Singh and I'm the technical director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Yeah, Arvind, you can take it forward. Yeah. Good evening, guys. Let's start the session. Okay. Today's agenda is that today we are going to discuss machine learning algorithms with using one data set called as an IPL predictions. Okay, this is a regression task. Let's first explain that what is that machine learning concept is that on after that we'll go back into that coding part itself, and we'll run with particular algorithms and see the prediction rates for that, and also modify and do some iterative process in that. Right. Let's go back into that. Let's go back into that. What is that machine learning part itself initially? I'll share that. So I just give you a brief note on that. What is that machine learning is all about. After that, we'll go back into that algorithm and run all that things which you are going to see that. Right. Okay. I think all of you are able to see the screen itself. Uh, uh, okay. The people now, as you can see, that the world or the globe is moving towards an AI platform. So on that. Okay. As you see in that very small startup to the large big giants itself, all are moving towards an artificial intelligence platforms where they developed all the GPT platforms to use that and reduction of the humans supervision itself. So they develop their own GPTs like a generative pre-trained transformer. They develop all their GPTs and give their responses from that itself. So that's what in the coming years itself, you're going to see all that pre-trained transformers running out in every platform itself. So you just want to give a response in a fraction of seconds. So in that couple of days back, you see that we have customer service supports all that, and the reply goes on within minutes to the hours and that. And you will be in the long run of call itself. So that could not be happen couple of years back, where we reach out to the super reinforcement learning itself. So still these semi-supervised as well as reinforcement learning is in that research and development stage it goes on. So when it comes back into that picture exactly, then that all the situations are being erased on that scale itself. Okay, right. So, in that couple of days back, we discussed that machine learning is one kind of popular techniques. Okay, one technique where we see that by using the predictions and further classifying the information and making out some necessary decisions in that. So, I'll not go much deeper into all that discussion part itself. So, I want to tell that how does this machine learning process will work on. So I just want to tell that initially that all the data, all that learning processes, I told you that machine learning is all about like four kind of learning procedures, which generally that people have been adopted on that scale. We have supervised, unsupervised, semi-supervised, and reinforcement. Okay. Before going into that talk with this, all these learning methods by the machine, so I want to tell that machine is going to learn some algorithms, all that is been trained on that procedures. We all know that with some algorithms, it's been trained and giving out some productivity output itself. So how do that machine has been trained on that? The first scenario is that how do that machine has been trained on that? So machine has been trained by only the data itself, by only the data, with the useful of the data. Okay, it reads and understands the data itself. So upon understanding the data, what are the processing techniques you are going to involve before learning the data, before sending in the data? What are the prerequisites, or nothing but what are the prerequisites? Suppose you're moving into that fourth semester. So you're learning the third semester subjects too, which have been consecutively related to your third semester. The fourth semester subjects have been. So your third semester subjects are the prerequisite subjects which have been connected to your fourth semester. Like that here also. And so we have a pre-processing techniques. That pre-processing techniques has been taken down with the data itself. With that data, okay, we do certain normalizations and also we do some future scaling or future engineering importance on that, and scaling procedures, and next we do some encoding techniques, all that. So these are some pre-processing techniques and that encoding techniques, and we do some PC analysis itself, like principal component analysis, or also we do some singular vector decomposition itself. Like that, there are various pre-processing techniques available before learning to the machine. Okay, before learning to the machine, because what is the reason why we don't directly give the raw data to the machine to learn that? Because as a simple example is that we give all the subjects or the books to guide to you itself. Okay, if we are not guiding you with the book or anything else, you're not able to learn of anything on that particular matter itself. So that's the reason here also we are completely delivering all the complete raw data into a useful purpose where that machine could understand and find out some kind of patterns with that. Okay, understand and find out some kind of patterns with that. So before going into that kind of patterns, we do some dimensional redirections and normalizations, all that techniques. After that mission is been the data has been completely in the picture, then we send back that in the processing techniques with some algorithms. Okay, that learning methods are first called as supervised learning. Okay, what is this supervised learning? Will do all that. So it's a one kind of learning methods in the machine learning techniques. Okay, use the data. Okay, it is use the data. Suppose you have answers for the data. So okay, you have a question and you have been answered for the data itself. You are also having a question and you are also having answers. And with that particular point of questions is been tested down with the original answers itself and compare with the machine answers which have been generated. Okay, we know the question and we also know the answers. The answers are called as labeled data here. It's a okay. The correct answers which you are seeing out are called as labeled data. So you already know the data and you also know the answer for the data itself. What could be your prediction rate for that? And we check the data. Okay, we check the data with the particular answers given out, and the correct answers and the compared prediction answers by the machine, and we compare with that answers itself. That's what you do, that the same thing. Like in the supervised learning, we train the model itself and we test the model. So upon, if you have a complete data set of 100% itself, so out of 100%, we share the training part of particular part and we share the testing part of some particular portion. And for the training part, we all know the answers for the training part itself. And for the testing part, we get the answers and already we know the labeled data itself. So you compare that predicted answers with the original answers itself. So what could be the accuracy itself? So if your accuracy is good enough, like if your accuracy is good enough, so how far it is comparing with the original answers, then you can identify that that machine has been learned completely or identified the data completely itself. So then next you give a certain question itself and it could able to predict the right answer itself. Then only we are going to identify that machine has been learn complete picture on that. So that kind of learning methodology is called as supervised learning technique itself. So I'll tell all that unsupervised and semi-supervised in the next session itself. Today we'll go back into that supervised learning. So why this ML is such popular? Why this ML is such popular in that? So as you can see that general programming generally seen that we have a data, so and their rules itself, and we dump that data as well as rules that, and we find out the output on that. But in the kind of machine learning, it's kind of opposite scenario. So we feed the data and also we feed the outputs on the data and set the rules by the machine itself and find out the regression techniques or the classification techniques or the clustering techniques, any kind of things. So there are several supervised learning algorithms available in the market itself, guys. Like we have supervised learning. In the supervised learning, we have linear regression itself, and we also have a logistic regression, decision tree, support vector, and k nearest neighbor, navy bias, boosting, all the boosting techniques like gradient boosting, XD boost, all that. Several algorithms been available for that supervised learning. So today we'll discuss few algorithms running out with some special data set called as IPL prediction data set itself. Okay. I think all of you are clear with that supervised technique. Supervised technique is, once again, I will repeat that. Supervised technique is the technique learns from the labeled data itself. Labeled data is nothing but the answers which you already known for that. Okay, we already know the result of the input data and we compare that prediction to the results of the data itself. How far that machine has been learned itself. Okay, that's what that supervised learning is all about. This is that process itself. Suppose as a simple flow on that. Okay, we are giving certain all the green, blue, all that into and dumping that into an algorithm process. So algorithm has been trained such and that all the green should go out in one class, all one classification, and all that rectangle portion should go out in one classification and all the triangle part should go out one. This is one kind of pattern identification, generally called as identifying the patterns from the data itself. So that's what is all about this supervised learning as a brief itself. So let's get back into that algorithms on that process. Guys, okay. Now, as usual, we start with the collab itself. Right. So, as usual, we start with the collab and new notebook. You put up 33. Let's connect to the runtime. So what we do first, we load the data set itself. Okay, today I'm running out with one data set called as IPL prediction itself. Okay, the first innings score prediction of the IPL. Okay, we're going to see that the first innings with different teams. IPL is a big platform for that our Indian market, and you see that. Okay, we do all that. Watch all that superstars in that match itself. So now we are going to see that. So on which team, on suppose the on which team basis the batting is going on. For that, how many runs could be predicted for that team? Okay, how many runs that the bowling team could be score on that, or whether this team is batting. Suppose one team is batting, some X team, how many runs would it score for the other team itself for these two matches? Like that, we are going to see the prediction for all the matches on that scale itself. Let's go back into that data set loading. So I load that data set. Is that data set available? Right, we are loaded. It takes little bit time, guys. After completing of this circle, only you need to copy that path. If you copy the path itself, so you will get a packages missing out. So only few packages or the few data will be stored for you. Other data will be overlapped itself. So until and unless it gets filled with that circle, before filling that circle, we are importing all the libraries. First, we'll import the libraries like pandas and speedy. Next, we'll import all the libraries like numpy as np. Okay. These are the basic libraries which have been imported. Okay. After we need to read the data set itself. What could be our data tf equal to pd dot read underscore csv. Just give a couple of seconds till it loads. Today we are seeing out, I told you that in the supervised learning, basically, we have two kind of techniques. One called as classification, other called as regression techniques. Okay. As you see that there are many algorithms available in the market. Like I told you that linear regression, logistic regression, decision trees, random forest, k nearest neighbors, Navi bias like XGBoost, all that are available in the markets. Like one algorithm, suppose if you take that linear regression, okay, it also used, it is been only used for the regression kind of data set itself. So if you do see the decision trees itself, okay, it is been used for regression as well as classification algorithms. Now we are going to see that regression algorithm itself. Now this is a part of regression algorithms, which now we are going to work out with. Sir, how can we identify that it's a regression or classification algorithm? I told you that. So classification itself tells you that on which basis you are going to classify that. Whether you are in the classification of yes or no, or 0 or 1, or you're classifying that like true or false. Like suppose your customer is going to do the sales or not. Like this is nothing but your classification things. When you open that kind of data set itself, you'll get to know that what is our target column itself. Some people ask that how do we identify this target column is that? So what is pandas and numpy? Why you are importing it now? Yeah. So I think this is your first class maybe. Like pandas and numpy are the libraries used for uh, reading out the data set and doing all that calculations works in that. NumPy is used for the calculations works and pandas are used for reading out the data set itself. So I'm loading this data set itself, which is called as IPL data set. So I want to read these data sets. How do you do that? I'm just reading the data set itself. So if you want to check that data set available on that, how do you check that? Df dot, right? Df dot ed itself. So no, yesterday we have seen all that. I think those who missed out classes, you find out the recordings, right? Where can we find this first two class videos, sir? You can at the end of this session, our team will contact you. Okay, in this class only. Okay, you can ask them any queries itself. Right. So meanwhile, you concentrate in the class itself, guys. Okay. So we have the datas available like this. Like we have a date in the match in the year of 2008. We have IPL started on that scale itself. On that first match itself, that match. So we have seen the venue, like we have seen the bat team, bowling team, and the batsman, bowler, and the runs, wickets, and the overs combined to that. And you can also see multiple fields itself. Like you can also see that total equal to triple to a non-striker, striker, wickets, runs, all that. So these are several columns available. I think instead of seeing all that, you can just see the columns here itself. Right. These are the columns available in that, guys. Okay. Now what we are doing is that your question, I think so. So we are going to predict that. Okay. We are going to predict the first inning score predictions for what is the team batting on. For that team, if other team is going to match, suppose we have a batting team of suppose what are the teams available, guys? As you can see that there are several teams. Suppose we are batting this RCB. For the match is against RCB to the Chennai Super Kings. So what could be your score prediction is that? So what could be your score prediction for the particular over and if how many wickets has been lost and how do you predict that score? This is what we are running out with this ML machine learning algorithms itself. I think the question is very clear for you. That's what we are doing it now today. So let's check the shape itself. Let's check the shape. First, initially, we are checking the shape. And next, we want to see that the shape is 76,014 are the rows available. Like that's a reason the data set is been loaded little slowly itself. Because the data set is having a huge number in the and the 15 columns, which are the columns is already shown to you. So in this, the mid is the column which is useless because it doesn't give any information to us. So we'll remove that unwanted columns in that. Okay, because 15 columns is a very huge column to read that and encode the data itself. And there are plenty of rows available and the date also, like when you and the batsman team, bowl team, the batsman, bowler, runs, wickets, all that. We'll see in the last five last runs, last five, last wickets, last 5 overs, who's the striker and the non-striker, what could be a total. All that we are going to see that the data types for that. Okay, what is these data types is that. So this is a machine learning regression problem itself, guys. Okay, this is a machine learning regression problem. Okay, right. As you can see that there are object, integer, float types itself. Okay, object type are nothing but your categorical type itself. Okay, object types are categorical type itself. So all that integer 64 is a int 64-bit type and float 64-bit types is are the numerical data types which are available. So all that we can see that all that. So now is that part is that now I am not going to run with that all the total data set. I want to concise my data set like according to my wish. So I'm considering that data set like I was just want to remove. I just want to remove unwanted columns. Like I just want to remove the unwanted columns. First thing is that because the columns are very high over there. And the next point is that so how could we know that, sir? How do we remove all that? It all comes with the practice only, guys. So how well you practice with different data set itself, then only you can understand the collaborating with the data set and what is the algorithms you are going to apply is that. Okay, the only thing is that you just want to practice with multiple data sets because this kind of data set isn't the complete different data set. Suppose if I load a diabetes data set itself, that is a medical related data set. Yesterday we have seen the cars data set itself. That is very completely data set. So the data scientists or that people need to have the clear understanding with each and every concept on the data set itself. First, you need to analyze the data set itself. Next, keeping only the consistent teams itself because there are various teams available. I will not go with all the teams. So I want to see that consistent team. Consistency means who are good enough in playing all that matches. Next thing is that removing the removing the first 5 overs scores itself. Okay, because we don't want that first 5 overs scores which are power play for that was data in every match itself. I'm going to remove all that because I'm just reducing the what I'm doing is that I'm just reducing the my data set itself because the data set is very huge enough. So I just want to reduce my data set itself. And next thing is that as you observe that, so why you're doing all that things is that I just want to reduce my data set scale itself. That's it. And to work on with the consistent teams itself, not to work on with all the teams. I just want to because there are some teams which are good in playing with all the other teams itself. That consistent team I have been checking out itself. I think guys are you able to follow that. Keep as if I want to reply from you guys. Right, right, right. This is very typical data set, guys, which I'm looking out at. How to get data set. Okay, I'll show you that at the end of the class. I'll show you that where to get that data sets from, where we can do all this practice with a different data set. I will show you in the end of the class. Okay, just ping me once at the end of the class at reaching out to the 9 itself. Okay, I'll show you that where we can find out all this. Yeah, Kaggle is a platform, but in the Kaggle, where is the source? We don't get directly all the data itself completely. We get with the raw data, with the missing all that data completely. So I'll tell you that. Right. So meanwhile, look at that. Right, where we are with that. I would just want to remove this first 5 overs because the first 5 overs score we are not going to predict. We are going to predict in the middle overs itself. We are going to predict the middle overs, like what could be the score in the first innings. Next thing is that I can see that date. Date is an object here. Okay, it's showing the date is an object, but date is a date type format. It should not be in an object type. Or also by data scrapping also from a website. Yeah, there is another website called as UCA, University College of Higher Ed. They also see the data sets. They also collect the data from different sources and put the data set in their platform called as UCA, University College of Higher Ed. Okay. So now, as you can see, that data is an object type here. Generally, data is a data type itself, date time format. That also we need to set out. Okay, initially I got that data is that converting that all that converting date column into date type column, date time. So generally you're seeing that it's an object type. Object type is nothing but a string type. Okay, these are that parameters which now we want to give that. Okay. Now let's check that df dot columns on that scale. Okay, once take that df dot columns because we want to remove certain columns in that because I don't want all the columns to work on with that because every column doesn't give any importance on that. Okay, we remove some columns in that. So columns to be removed. Okay, I just want to remove that columns. Okay. Columns underscore to remove. Okay, I just want to remove the columns. Okay. What are the columns? We can remove that. Okay. We will remove few columns like first column is mid. Okay. It doesn't provide any information as you see that guys. And next column could be your venue. Okay. Venue also doesn't matter with that predictions onto that mainly, but it matters with the pitch itself, but it doesn't matter with that. Okay. Next column is batsman. Okay. Next column would be your bowler. And next column would be your striker. Okay, these are all that we are removing that. Okay, so I just want to tell you that this could be not that thing that which everyone should follow. You can choose that go with different parameters itself. Okay, that's your wish, guys. Okay, which is non-striker, striker and non-striker. Is the spelling correct? Yes, I think so. So this is what I'm doing that. Okay. Now, if I drop these columns itself, okay, if I drop these columns, like, what are the columns I want to drop, guys? df dot drop, df dot drop on that columns. So I just want to add a few things of parameters, like what are the columns to be dropped on there. Okay, before doing that, I just want to find out the shape also, guys. df dot drop of labels. Okay, labels equal to, what is that labels now? Labels equal to columns. What is the name I have given? That are that columns. Columns to remove. This is that. Comma, on which way you want to drop? Axis equal to 1. Comma, axis equal to 1. Because that is dropping that throughout the column wise. Dropping that in the column wise. 1 will be your column wise, 0 is in your row wise itself. And comma in place equal to true. Anyone, if you know that in place equal to true means with that only positions you are going to drop that. With that in the positions you are going to drop that. Okay, this is a way if I drew that itself and check that data frame shape after that. Okay, what is that mistake we have done? Is that spellings mistakes going on? Okay, batsmen's before I have written something. Right. Okay, let's check the shape of this. Let's check the shape of that, guys. Yeah, any question? Batsman, sir. Yeah. Yeah. Right. Let's check that. How many rows have been removed out, guys? How do you check that, guys? How do you check the shape? Like df dot shape. Yeah. So how many that removed? That's like, so in the previously we have 15 over there, right? Okay. 76014 comma 15. Now it becomes 76014 comma 9. So how many columns we have removed? 6. I think, yeah. 1, 2, 3, 4, 5, 6. Yeah, 6 columns now being reduced over there. Now it is cool that, okay, now we are working on with all that data set like. So I just want to do that next step is that like I want to see that batting team, how many is that unique available, that how many batting teams on that, because what is our next step is that, guys, keeping only the consistent teams only. Okay, first thing is that removing unwanted columns. I did just done that. I just want to keep that only the consistent team. So first check that what are the bad teams available, like bad teams dot unique. Let's check that what are that bad teams. Right, there are so many teams available in that, guys. So I don't want all the teams itself. I just want to see that consistent team only. So I just use that consistent team itself. Okay. I already taken that consistent team in one list over there. So I just copy that consistent teams. So like what are the consistent team available, guys? Mm, So we'll take only the consistent teams like we have teams. These are my consistent team, guys. I just pasted out over there because I typed it the word like Kolkata, Chennai, Rajasthan, Mumbai. Like these are the few teams like consistent teams only. Okay, in that all the teams, I'm only taking the consistent teams itself. So that could give me my reduction of the data. Why you're doing all that sense that I just want to do precise with the data. I just don't want to use that raw data completely itself. I just want to precise my data and use some techniques to find out that predictions. So that's what I've done that. So I've done that consistent teams only. I've done that taking the consistent team only. So after that, keeping only the consistent team, I'm just removing all that teams over there. So what I do, so I run this consistent team on that. Next, keeping only the consistent team is my next one. Okay. I just want to keep my only the consistent team. Okay. What I do, I just take batting team is in inconsistent. Okay. And do all that iteration process on that. So next, df of k equal to df of, I just want only the consistent team over there. Okay. What is that of df of, is that batting team? I just want to do that batting team only, batting team. Next, with is in consistency. If they are there in the consistency team, then that could be keeping. Otherwise, you just replace that. Okay, if they are in the consistency team, only keeping. Then otherwise, you just remove all that elements over there. That's it. I want. Okay, guys, that's what I'm doing. All that. All right. What is it? df dot is in. I just copy this name itself instead of writing all that. Is in next. If they are there available in the consistent team itself, and the bowling team in the consistent team, the same bowling team also we are taking that because the bowling team and the batting team should be in the same ratio itself. Okay, and same I will copy over there. Okay, just to copy the same thing over there, guys. Right. Now our DF will become only these kind of consistent team only. Okay, something mistake. Name consistent teams is not defined. Okay, did not run that. Yeah. Now it is fine, guys. Now let's check the df dot shape here. Okay. Now let's check the df dot shape here. I think all of you are following, guys. Now check the df dot shape over there. So, or let check that df dot shape. So because how many we are now doing a scaling process, guys. Now we are doing that scaling process because I want to. So previously, how many are there, guys? Previously, how many are there? So in that previously we have 76,014. Now I got 53,811. So these are certain numbers of reductions. Okay, now my data set has been completely down itself. Now we are just not reducing the data. So all the guys able to follow me? Just need a quick reply. Okay. Okay, next, what is that? So now what are those batting teams available? That let's check that. What are those batting teams available? Let's check the unique of the batting teams available. Like now we have done that consistence over there. Now let's check that TF of batting bat underscore team. The bat underscore team dot unique. Suppose I want to see that unique parameters over there. Just go and see that unique over there and check that. So these are the teams, guys. Finally, we made out with this team. Okay. Now it's time to look upon all the parameters like. So I told you that what is the next parameter, guys? So now I reduce all that. Next, removing the first 5 overs data in every match. So for every match, now that scale is reduced, guys. How much is that reduction, guys? Now, how much is the reduction I got? I got finally from 7,600 to 53,800. Now still I want to reduce because this is a huge data set itself. Okay, this is a huge data set. I just want to drop down to I just want to see that after the first 5 overs, what could be our rate itself. Okay, why you are seeing that is that I just want to check that score prediction only after 5 overs, not before the 5 overs, guys. Okay, DF. Okay, with that DF of overs, DF of overs. Because overspelling. Okay, now doing that column means because. Right. What is that? Over should be. What is it, guys? Over should be greater than 5. Yes or no? As you can see, the data set itself. Let's go back into the lookout once on the data set. So overs, you can see that every bar, it's showing that 0.1, 0.2, 0.3, for all that it is showing. Now I want only the data which the overs should be greater than 5 itself. It is clear? So this is all about your reduction of the data itself. Let's look back the shape. Let's look back the shape once again, guys. So will it has been reduced or not? Yeah, it has been reduced to so many over there. So 400, right. Now next thing is that I want to set my date time into a time format itself. Like this is that format which we are going to set that pd dot to date time of df of date, comma. This is the format. So in this case, this will set you the format itself. Let's check that df dot what is that info. Okay, whether it's changed or not. Right. Date object time is now converted. So no, date object type is now. And in the previously, when you see that the date is been an object type. So no, the date is been in object type. Now I converted date time into an date into a date time format itself. All of you, it is clear. Now what is that next thing is that? Next thing is that now I want to convert that column date. Okay. Now if I want to see any correlation features on that. So if you want to see any correlation, you can look out that. So I don't want to see the correlation of every features because I still want to find out with only the columns which are available. If you have so many of the columns available, you want to just see the correlation between the features by using that matrix itself, like import matplotlib dot pyplot as plt, and also import cbone as SNS over there. Okay, after this running, I just want to see the correlation between that guys. Okay, to get a correlation of all the features, I just copy paste that code itself because I don't want to type all that. Okay, let's run that. Okay, you can see that the same correlation of the matrix been available for that, guys. Yes. So this is what the heat map like what previously we have seen. I want just the top correlation features on that scale. Okay, I just pushed out that with top correlation. And you can easily observe that like runs, and this is like runs. You got all the diagonals will be the correlation, all the diagonals will be one only because so the runs is correlated with the runs, then you'll get 100%. That's it. We know all that. Now, what is the other columns? Like you can see that 0.88 is a correlation. Observe that for the runs to overs. Okay, that's what overs is correlated to the runs. That's it. We know that. So I think I not find any other correlation other than that. And these overs and runs only. You can see that. So it doesn't matter with that. Okay. Okay, next now we are decoding the process. What we are doing, guys? We are decoding the process. Because why you are decoding all the process? That is called as data pre-processing techniques. That is what called as, guys, data pre-processing techniques. I'll write all that. Now we are doing that data pre-processing techniques. So in that data pre-processing techniques, what you do? We just handle the categorical features. First, we handle the categorical features, and next just split the data itself. That's it. We do that, and also we split the data itself. So handling categorical features. Categorical features also called as object. So you have seen the object features, guys, in the previously. How many objects are there? We have seen the info over there. Like these many objects are available. Like first and second one is the object. So now I want to convert this object into a numerical features. So that what I do, I just do my encoding techniques called as encoding techniques. So how do we do that encoding techniques is the simple things. To convert that categorical features, okay, the first thing is that okay, to convert categorical features, just writing a simple statement. Okay, if the spelling mistakes are there, please don't follow me. Then categorical spelling is wrong, I think so. Just adjust to that. To convert categorical features or the features into numerical features. Why you are doing all that, sir? So because when you're training the models, so you're going to train the models with the train and test data. So upon doing the train and test data, all that features should be in a numerical values itself. That could be very much feasible for that. So for that, converting all that, we use one-hot encoding techniques. What is that called as? Just we use one-hot encoding. So we use one-hot encoding technique, guys. So what is this technique? Let's see that. So now we have several columns to be converted. So what are the columns to be converted, guys? We have a columns called pd.getDummies, and df of what is a df is a data, and columns equal to bats team and bowl team. That's what these are the two columns. I think so. So no. So bat team and bowl team are the objects. That's it. Other are all numerical columns only. This is integer as a numerical and float is a numerical. And the other one is date type is that. So we don't touch that. Okay. We are seeing that now it's time to convert that columns into an encoding technique itself. So that's what we have done, that encoding. So let's run that encoding technique over there. Yeah. So upon encoding techniques, okay, these many columns will be generated, guys. Okay. So upon doing this encoding, you can see that date is done, runs, we get source, and last 5 hours total. And bat team, okay, what are the columns are available, guys? Bat team and bowl team are the two columns of objects. That objects are now that two columns, like batting column and bowl team columns, which are unique available teams, are now converted into these many columns itself. Are now converted into these many columns. So what does it mean, sir? It means that all the columns are now encoded and only digitized into a format like of 0 and 1s only. What is that it does? It done only 0 and 1. Let's look up this head itself. What is the data frame name, guys? Encoded dot df. This is my data frame name. I copy that data frame name. I think all of you are following, guys. Okay. No, it. So you can see that there are any numerical column, guys, now. Yeah. I think a response from that, you guys are you able to follow me? Yes. Yeah, right. All of you ping me, yes, if you're following. Right. Good. Okay, those who are new to this concept, it takes little time. Okay, don't worry with that. Okay, I'm just going with the flow of very slow itself, guys. I'm telling that what we companies people will do that with in short explanation again. What all have you done? Sure. At the end, I'll show you that all the explanation itself, guys. Okay, no issues that. Sure. I'll go with the conclusion itself for that. So now I just want to complete then show you the predictions itself. That's what in the motto I was going on. Like in this, you can see that. Because now in the previously where we have bat team and bowl team columns are available on that. So now that columns are object columns. Okay. As you can see that what are there in the bat team and bowl team columns? Let's observe over there. The bat team and bowl team columns having the team names itself, the team names. So suppose what does it do? Encoding will do that. So batting columns, how many unique column names are available? Like we have KKR, we have SRK, we have SRH, all that are there. That all are converted into individual columns. All will be converted into individual columns. Suppose this we have a KKR underscore batting. So all that column names, all that columns where KKR is available, it will put 1 over there. All the rest it will put zeros. Like that, how many names are available uniquely? That many columns will be created. Okay, that many columns will be created. Okay, like what it creates, you can observe over here, like guys. So as you can see that, so bad team Chennai Super Kings, where Chennai Super Kings names is available, it will put 1. The rest of that 0. So like that, all the teams will be created like that, like bad team Delhi Super Kings, like Kings 11. So in the previously we have names over there. In the batting we have names. That is called as object. Now we converted that into a numerical type itself. That's what we have converted into a numerical type over there. Okay, guys, right. And next thing is that now what we are going to see that we are now going to rearrange the columns, because all the columns have been jumbled over there, like date, runs, wickets, all that have been jumbled. It doesn't seem good over there. I'm just rearranging the columns, which in my order over there, to get smoothing of working on that chapter. Okay. So I'm just rearranging the columns. Okay. I just copy that cell which I pasted. I want to paste that because I copied that in the notepad. I just pasting out over there. Okay, nothing much I have done exclusively. Thus, okay, all this order is there. Okay, you can see that all this order is there. Okay, all this order, I'm just rearranging that according to my tools itself. That's it I've done. So all that date is the first one. All the bats team, and after that all the ball teams are available. Next we'll go back into the runs, overs, wickets, and last 5 overs and total all that. I'm just rearranging the column. That's it I've done. Why you're rearranging that? It just depend upon yourself. You can rearrange on, you can do that. So now, now the step is very important, which I'm telling is that, okay. And now splitting the data, okay. So why you're splitting the data itself? In the machine learning, we are splitting the data to the training part and test part itself. So why you're doing all that? A simple example, I'll tell you that. So you're reading all the subjects throughout the semester itself. Okay, you're reading all the subjects throughout the semester. Means a teachers are training you itself. Throughout the semester, teachers have been training you. So now at the end of that, at the end of the semester, what you do, you're writing the end semester examinations or not. That's what the test is all about. The test is what? So what you have trained till now will be testing out on you. What you're trained out till now will be testing out on you itself. So whether if you got good score itself, your training has been very much successful itself, and your test results are good itself. Okay, that's what it is going to do that. So here also the same phenomena being applied over there. Nothing magic or rocket science being there. So mission, okay. Now suppose I am the mission. I want to learn something. So you give the training. Okay, you give the training to me. And after training, you will not leave as is to me. What you do, you test on me. You will do the testing on me. If the results is good enough, my training as well as testing is productively done. If my results is not good, very bad itself, then somewhere you're failing. You're failing either in the training part or in the test part. Like your your middle exams, like your middle semester exams, what is that, you have like assignments, midterm examinations, all that, your performance is very good. That's what in the training process, your performance is very good. And at the point of end semester examination, your performance is very low. So that's what I'm telling that. So if I fail at that process of testing itself, so if my predictions or the score of results is very bad itself, okay, the fault will be in that part of training part or in the part of test part itself. It could be any part. Okay, we can't judge that where is that prediction goes on wrongly. Okay, we need to check that in that training as well as test set part itself. I think all are able to follow me. Splitting the data. That's what I'm going to write that. I think all of you are clear with that. Right. So this is what mainly done for the supervised, all that algorithms, all the machine learning algorithms, not only machine learning, all the deep learning, all the neural networks, all that everywhere the same process. Where you work on with the machine, the same thing. You are splitting the data. Where you have original data with 100%, you are splitting the data itself. You're splitting with some percentage. That's your choice. You can split with 80% of the training to go to the training part, and 20% of the data should go into the test part itself. That's your wish. That depends upon person to person and working with the data itself. Okay. There is no such restriction telling that this could be the portion going on to the training and test part itself. Right. Now what you are doing, splitting the data into train and test set itself. Into train and test set. Set means it's a couple of data has been available. Now I want to set, like I want to see that. Now I am running on the data. Which data? Encoded underscore df, because now encoding is done for all the columns. Now I am going to run with the data. Now what is that? I want to give the test set. So we have a years upon. So I want to test on 2017. Okay. I want to test on 2017 prediction results only. So I want to train on the values which is less than 2016. I want to test that. What do you do? Decode encoded underscore df dot drop if there are any values. How do you're going to drop that? What values you are going to drop? Which is less than or equal to 2016 values you're going to drop. Labels equal to total. All that label, which is the total, is my prediction. Okay. This is my target column, guys. That's what I'm telling them. This is my target column. What is your target column? Total. I want to predict my total itself based on all the futures itself. Like all these futures. These are all the futures. These futures are related to the target column itself. This is my target column. That's what I'm going to predict. That's what labels equal to total. Axis equal to 1. I'm just doing all that. I'm dropping this only one column because I'm not feeding the total column over there. I'm dropping this column and all the other rest of futures are going to be trained over there. Okay. With including the data. Of what data it should include? With the date years which is less than or equal to 2016. That date only it should go. And then for test, this data should go for the training part. Now what is that? The data should go for the test part itself. Now the test part is that data should move out with the, what is that? With the 2000, which part it should go out? It should go with greater than 2017, guys. It should go with the greater than 2017 of that values. Okay, I'll just copy that and it should be greater than 2017. Clear? My training portion is still up to 2016 and my test portion is greater than 2016 of the year's data. Okay, this is all about your X and Y itself. Now I have done X and Y. Data has been taken down. Now, X has been taken down over there. Now it's time to move out with the Y data. So what to be there with the Y data, guys? Any idea with that Y data, what to be there? Y data is all about your target column data. What is it? Y data will be your target column data. So like encoding of decoding of the data, date. What days of the column should be there? In the X train, what are the days are there? Which is less than or equal to 2016 are days. So I am dropping the total column. I am including all the columns. I am including all the futures. Nothing but the columns. And I am dropping only the total column itself. Now I am only including the total column because Y is my target column. X is my labels column itself. Okay, like X is my future column, Y is my label column. You can take any other way. Y is my label column because label column is nothing but my target columns itself. X is nothing but your all the future column with all these futures like date, batsman, these batsman is belong to this category and bowling is belong to this category. Suppose batting is Chennai and the bowling is Mumbai. So what could be your prediction? That's what we are going to see now. For different cases, like if the batting team is this team like Chennai, for these many overs and these many runs are there for that over and these many wickets are available for that time and the last 5 wickets if it is 0 and last 5 wickets lost or runs it is 0, then what could be my total score itself? Okay, what could be my total score itself? That's what we are going to find out over there. So that's what in the last we are going to see all that things. Okay, in the meanwhile, removing the date columns itself. Okay, we'll drop the date column for all the rest of that things itself. For the rest of the things, we'll remove all the date columns like noting down X train dot drop of labels equal to date, axis equal to true, and removing all that itself. Okay, we will put your test over there. Right. Okay. Now I just run that itself and also see the shape. Now I splitter the data. The data splitting has been done or not. Let's check that, guys. How do you check that splitting has been done or not? Just simple xtrain dot shape and extend dot shape. That's what. Whether the splitting is done properly or not. Yes. Xtrain is that over. And now we check back into that X test over this. Guys, any doubts till now? I just to ask you that. Any doubts? Are you able to follow? The simple thing is that I just splitted the data. That's it. I just splitted the data over there. Yes, guys, give me a quick replay over there. Are you able to follow me? Yes, yes. Yeah. Keep on posting. Now I've also seen the X shape of it also. X test. Because train and test has been done properly or not, right? So now you can see that, okay, you can see that here less than or equal to 2006 means the matches which has done for below the 2006 have a data of 37,000. Okay, this is a data having the data of 37,000. And for the year of 2017, we have a matches of the data of 27,000, also 2,778 itself. Okay, that's it. We have the data. So now let's go back into all the details. Like now splitting is done completely. Now it's a process to check on that model building. What is that now? Model building. Now we are applying all that machine learning model, guys. What we are doing? We are now applying the machine learning models. So that's what called as model building. Till now, the splitting has been done. Okay, this is supervised learning. Which one we are doing? Which model we are doing, guys? In the supervised, which either classification or regression? Which one we are doing? Just give me a quick reply. Yes. Yeah, come on. Yeah. We are doing, what is that? Regression, right? Super. We are doing a regression. Now, Okay, now it's time to load, apply all the algorithms, playing algorithms. So I told you that there are various algorithms for the regression itself. There are various algorithms for the classification also. Some algorithms use both classification and regression part also. So first we'll import linear regression. Linear regression, guys. Next we'll do up with, we'll go and try with some other models like a decision tree regression. So we'll try with couple of models, not all the models, guys. Like decision tree regression. And next thing is that we'll go with the random forest. So these are very powerful models, guys. I want to tell that these are very powerful models. So, sir, you're telling that these are very powerful models. So, why using all the models? We will go with one only one model which is powerful. No. Every model doesn't understand with equally the data for every time. Every model doesn't understand with the data of each and every model with the same thing. Because as a simple example, I will tell you that. So, I am good in this kind of data science program itself. Okay. Suppose you think that, okay, so I only understand these kind of concept. If you tell me that medical coding itself, I can't understand that. I'm not able to understand that. So I can understand for 1 or 2 days itself. For the next rest of days, I'm not able to understand all the concept itself, because I'm not able to grab that data and find out some things from the data itself. That's what the model is all about. The model also identify, model will apply good for one data set. For suppose these data set, suppose in this data set, linear regression model applies good, suppose. So for that other data set which you are giving out for the regression, decision tree will work fine for that. And for other data set, random forest will work fine. So this all depends upon the understanding of the data by the algorithm itself. That's we can't do, estimate itself before that. So it's all about dealing with the data itself. That's it, and understanding the data with the algorithm. That's it. No other option available. Right. We'll go back and do with this these three kind of data. So these three kind of machine learning algorithms. Applying these machine learning algorithms. In the machine learning, what is this? In the supervised learning. So this is a supervised learning of regression itself. So tomorrow we will work on with the recommendation engines and the time series forecasting itself. Like I'll tell you that what is that recommendation engine, because all of you are aware with that recommendation engine which is running out in that itself, in the real world itself. So these are all the real world scenarios that which we are applying that. So I'm getting a value error. Why should be one dimensional while model fitting out? How can I fix it? Yeah, if you are doing that value error in that linear regression, put double list into that values itself, guys. Double list means open the square brackets and open the other square brackets and give that which futures you want to import or which target column you want to give. That's it. It will convert that one dimension to two-dimensional array. That's it. Right. Right, guys. Okay. This is applying a machine learning supervised algorithm. First algorithm is what? Linear regression. Okay. The first one, regression algorithm, is a linear regression, guys. So how do we do with that? Okay. So for running or reading the data, what is the library we have used that, guys? For reading our data frame, what is the library we have used? Guys, for reading the data, what is that algorithm we have used? Sorry, what is that package we have imported? Pandas. Right. So for reading that, we have imported pandas itself. Like this, for working all this machine learning algorithm, we have one library called as sklearn. sklearn is a package. Okay, the shortcut is sklearn. Generally, it is called as scikit-learn. It is called as SCIKET, scikit-learn itself. Generally called as scikit-learn. Okay, all the machine learning libraries, so all the machine learning algorithms need to be imported by this itself, by this scikit-learn only. Now I am doing my linear model itself. From sklearn dot linear model, import what model you want to import, guys? Which model I want to run? Linear regression. First one is what? Linear regression. When you're typing itself, it will give you all that intelligence. So now I want to import all this and do that instantaneously, that model. I want to do my instantaneous. So how do you do that? Suppose you are taking that linear regression on that scale. So I'm doing that linear regression. Like linear underscore regretters. So anything variable name you can specify. Just we are instantaneously using this linear regression over there. I'll copy this. Okay, I just fitting down now. Now it's time to fit that model itself. So how do you fit that, guys? Linear regression. I'll copy this. Okay, linear regression dot fit. I want to fit my data. I want to fit my data. What is the data? X train and Y train are the data. I want to fit this data to this model. Which model? Linear regression model. I want to fit what data? X train, comma, Y train. It is clear, guys? I am fitting the model itself. Now I will run that. Sorry, X is capital letter, I think so. It works. Yeah. So after fitting the model, it will give you the result like this. Linear regression has been fitted to our data, like X train and Y train. Okay, guys. Next, if you want to predict the results, we'll go back and predict the results itself. Simple thing is that Y predict the score. What is that? Linear regression. Because we are doing couple of models. So we are doing couple of models. That's the reason I'm just giving out to understand that. So what is this name? Linear regression name is linear regression dot predict of which test you want to predict, guys? What you are going to predict? Predict our X test data. Okay, that are our questions. And that questions. Y test is our answers, original answers. X test is the questions and Y test are the original answers. Y prediction LR is the prediction results for the X test questions. Okay, I'll not run this. I'll just run that. Okay, I just run that. So if you run that, you'll get that all that things itself. Now the process has been done. Now, next, what is that algorithm we need to load, guys? Like that, we are going to load all the algorithms, like decision trees, all that. I load that next algorithm. I'll write here. Which algorithm is that? Playing decision linear regression model. Right, guys? Are you able to follow? Okay. The process is not yet completed, guys. Till there, the process to predict the results. That's what the main thing is that. Right. Now the process has been done. Next thing is that now I want to do my decision trees. That the code is also the similar code. Like what is that? Nothing is changed over there, guys. Okay, the same in the place of that decision tree. I am just writing my in the place of linear regression. I am just writing my decision tree regressor. Okay, if you want to run this decision tree regression model, you are just going to write that decision tree regression from sklearn.tree. So this is a tree-based classifier, okay, and regression. This is a tree-based classifier and regression. That's the reason we are importing that. This is a linear model, okay. This is a linear model. From that linear model, you are importing linear regression algorithm. And from the sklearn.tree, we are importing decision tree regression. So this is a way of importing all that things itself, guys. Right, okay. We are running this model, right? After running this model, we got these kind of fitting is done. If it is fitting is done, you'll get that. Next, we need to write Y predictions for that also. Okay, we write the same thing of that. Okay, I'll write the same thing. Just to copy the above line over there and write that. Right. For the decision tree regression, we are writing that. And we are also running for the decision trees. Okay, till now the results is not been predicted. Just wait that. We have another process. A simple process has been there over there to check out that. Next, what is the next algorithm, guys? After decision trees, what is the next algorithm? We have other algorithm called as random forest. We'll also check that random forest. So how do you import the random forest? We are going to import this random forest by ensemble method. Ensemble method is nothing but ensemble. The meaning of ensemble, simple I can tell that. The meaning of ensemble is the combination of decision trees. It's a combination of decision tree. Earlier you can see that decision tree means it's a one tree. So in that random forest means random forest. In the forest, you are seeing number of trees. Yes or no? In the forest, no one will go and plant the trees in the forest. It grows by itself. The trees will grow by itself. Is that kind of trees which are grown by itself as a randomly, and that kind of combination of trees called as random forest. Okay, that's the name it comes under. It's called as random forest itself, guys. Right. Okay. Next, running this cell itself. Next, we are also predicting that process over there. Like doing the same prediction line. Okay. We're doing the same prediction. Okay. Now you got that thing, and also doing that prediction underscore regressor. Random regressor is our name, the prediction. Okay. Why you are writing all that is that at that last I'll get a conclusion on that. Now a simple process is been there. Okay. So I'm applying these three techniques over there, guys. Only the three. There are several other techniques. Now it's time to predict all that processes now. Okay. Now I just want to tell that these line of code which have been taken down. I just want to explain that code itself. So after that, I want to give a thing is that I want to check for each and individual matches. How do this process goes on? Like, so I want to check that. Like I want to predict that score itself. I want to predict that score based on that. Like batting team equal to, if the batting team is equal to Chennai, then it goes into this for if loop. And if the batting team is equal to Chennai, it takes this temporary array of the values. Like these are the values, like 1, 0, 0. If it is batting, it becomes to first one. If your batting team is second one, the number of sequence. Like that, we have calculated into how many teams? 8 teams are there total. Like 1, 2, 3, 4, 5, 6, 7, 8 teams. Like if the first team is, if the batting team is Chennai, then we put 1 over there. If the batting team is equal to Delhi Daredevils, we'll put 1 over in the next. Like that, that sequence has been followed over there as one. So why you are putting all that? To recognize that element of the array, that if the batting team is Chennai, we have already encoded. We have encoded, guys, previously. We have encoded like Chennai Super Kings as 1, Delhi Daredevils as that 2 on that scale, which is in the 2 order of the index. Like that. And the Punjab is the 3 of the encoding. It's been done. That's what the order is all about. As you can see that. Yes or no? This is the order or not? That's order only I have taken down. That's it. That order only I have taken down itself. So now what you are going to see here? So you can see that batting team is equal to Chennai. Then the bowling team. The same way we are also kept the bowling team in the order also. The same thing. The bowling team equal to Chennai. Then so the bowling team is equal to Chennai and the batting team is equal to suppose Sunrisers. What could be our score predictions for when you are going to find out the score predictions for the overs? As you can see, for the overs, okay, guys, for the overs, okay, we have removed below 5 overs. Okay, our over starts from where, guys? 5.1 only. Next, if the overs is 5.1, runs equal to 50, and wickets equal to 0, and runs in the previous 5 overs is 50, and wickets in that equal to, okay, wickets in the previous overs is equal to 0. Then what could be our prediction rates itself? That's what I have given in the initial stage itself. That's it. I have done here. Okay, I think all of you are clear with that. Okay, this is what a temporary variable store it in the list itself. Okay, I'll run this cell itself. Okay, now cell has been run completely. Now it's time to go for that return results of the predictions itself. So to find out the return results. So temporary array, what is being stored as a temporary array? What is the array of variables? With all the variables, including these, are being included, taken down. And these arrays are now converted into a temporary array by using an numpy arrays over there. We are converting into an numpy arrays. Then only our results will get included. So our results will get included over there. And we are going to predict that return. Okay, our return statement should be an integers with a temporary array over there. So when we predict all that results over there, guys, when we are going to predict all that results, so now it's time to predict that. So if I take that prediction on that scale and I want to do that my predictions like final scale, if I put that, okay, I am going to predict between that, what is that? Teams between Kolkata and Delhi Daredevils. Suppose I'm going to predict the Kolkata and Delhi Daredevils on the teams. So first, initially, I write over there. I'm going to see that prediction rates on that. Right. I got the prediction rates of 159 to 174 is the score being estimated. When you are going to estimate it, I can see that batting team, if the batting team is Kolkata, if your batting team is Kolkata, means Kolkata, then this temporary array will go into this category and take that into this category. The batting team is Kolkata, where it is, okay, it takes this temporary array as a storage. And the bowling team, if I'm giving that bowling team, what is my bowling team? Bowling team is equal to Delhi Daredevils. If your bowling team is Delhi Daredevils, then it also store that temporary array. Like if your bowling team is in Delhi Daredevils, then this matrix has been taken down. Otherwise, it takes 0, 0, all that. And we are predicting for the over of 9.2 over at the overs of 9.2. If the runs is 79, if the runs is 79 and the wickets fallen is 2 wickets, suppose I'm giving the 2 wickets and the runs of the previous 5 overs, that's the reason I have been removed that. The previous 5 overs is 60. How many wickets fall? It is 1. Then what could be your projected scores itself? Okay, what could be your projected score? Final score minus 10 plus final score plus 5. Okay, it is minus plus or minus 5. We are giving that range. Okay, what could be your projected score? Your projected scores will be your at 159 to 174 itself, guys. So this is what it has been predicting over there. Suppose if I am going to change these names over there, if I'm going to change these names, like suppose you want between sunrises and RCB, suppose if I change the values over there. Okay, let's see that. Okay, if I change these names over there, okay, let's grab to change that names and the values. Okay, we'll go back and collect that names over there, like sunrises. Now I am going to see that sunrises. Okay, this is what that IPL people also going to do that kind of predictions over there, guys. So after seeing after the first 5 overs over there, it will show you the prediction scores itself based on the overs. It changes. That's what this algorithm is running in the back end. That's it. Okay. If I take the batting team as Sunrisers and if I take the bowling team as Delhi Daredevils only, and keeping that values like 9.1 suppose, and the runs is 60, suppose the runs is 60 and 0 wickets have fallen, and the last 5 overs it is 60 and the wickets of previous is also 0, then what could be our prediction score, guys? Let's check out. Yeah, the prediction score would be 155 to 170 only. Okay, when it is being the matches with the Sunrisers to the Daredevils, because there are many permutations done beforely, because the model is trained such that. So when you have these kind of combination, like this match to this match, what could be the results? Based on these values, it has been forecasting that or predicting that itself. So it could be some like -10 to the final score to the final score to the +5. It's a margin like, because you not get such accurate results by this. Yes or no? Suppose if I change some other values or some other teams, like some other teams, which team you want, guys? Just ping me. Sorry. Yeah, someone is asking about CSK to RCB. Right. Let's see that. Give me your data, like how many overs and how many runs are there at particular overs, and how many wickets, and what is your runs in the first previous 5 overs and wickets of the previous 5 overs. Let's check for CSK and RCB because there are so many fans over there. CSK, I think CSK would be batting and bowling will be RCB. Let's check that. Right. And next RCB, where is that RCB? Right. Right. I'm keeping the same thing over there, guys. Would I keep the same values? Yes, I'm keeping the same values over there, like 9.1, like 60 and 0 wickets. Suppose if I take that 2 wickets fall, let's check that. 2 wickets over there. Okay. Let's look up that. Runs equal to 100. Okay, good. Okay, let's run that model. Yeah. What is that? Predictions? You are getting 185 to 200, guys. This was a prediction score itself. Right. So this is what that prediction goes on, guys. Okay. You can check with any kind of algorithm and do that kind of predictions over there. Right. Okay. I will conclude this from first itself, guys. I'll conclude that. Okay. I'll conclude this. Right. Let's go back into the first, and I think all of you are clear with that. Let's recap this session once again itself. All right, guys. So initially we load the data set. So initially we load that libraries which we want. Okay, importing the necessary libraries over there. Importing the necessary libraries is done. Next, loading the data set. And first, initially, what is that thing you need to do is that. So I need to check the data itself. Initially, what is that data set? Like what, how many, I'll check the columns, okay? Because I can't scroll each and every time like this. I just go with that columns itself. Or what you do, df dot columns, and you'll check the all the columns like what are listed out over there. Shear okay, all the columns are listed out over there. Next, we check the shape of that. Okay, the shape looks very huge because we have so many. What are those? We have so many columns available to that, and we are also having so many. What do I could tell them that so many rows also available that. So I want to reduce that things itself. I want to reduce all that rows and columns to that. So I go with that flow like because I studied. Initially, you need to understand the data. Then only you can able to do that process, EDA process called as exploratory data analysis process. So until and unless you don't know how to able to understand this data, so you're not able to do all that process. So I understand the data and I just want to do all these processing things. Like what are the processing things? I want to remove the unwanted columns out of all these columns. Like there are several columns. Because when you observe that, this column doesn't give any meaning to me. Like mid column, this is 111. So all is one only. It doesn't give any meaning to me also. Next, the date column is being required for us. And venue. Okay, the venue matters for some cases. Okay, venue matters for some cases. So I it's just a perspective of that doing all that. Okay, and like that I am removing some other columns. Like I want to remove some unwanted columns like who may be the bowler because IPL is a one kind of predictions which is unfaithful. That the last over also our predictions maybe fails. So depending upon the bowler, all that things. Okay, it depends upon the matter itself. So I'm just removing that some unwanted columns such as like uh, mid venue batsman who may be the batsman itself and who may be the bowler itself like and the bowler striker who may be the striker or non-striker it I'm not mattering all that. I'm just looking out with the team's perspective itself. I'm not seeing out with that because the players are moving each and every way. So I'm looking only the perspective itself with the team dependencies. So I will remove all these columns. So how do you remove that? So we just put that in a one list over there. We just put that in a one list and df dot drop. So df is the original data frame. So in that I want to drop the labels. What are the labels? Labels are nothing but your columns. These columns which are there in the list I need to drop over there and the axis equal to 1. And after dropping that, our data frame should be in ASCII. No change in our data frame. Should be in ASCII. Then what I do? Just I click in place equal to true over there, guys. I put in place equal to true. So after putting in place equal to true, so our data frame will not change anywhere. So it becomes constant over there. Okay. After changing all that. So I have done that. I have removed all that unnecessary things of columns. Now our data frame is reduced the size from 15 to 5 columns. But this is what some process. Generally, we do this process in the PC and SVD, which is principal common component analysis. That's what I told you in that PPT itself, which is a pre-processing techniques called as dimensionality reductions. So generally, we do that dimensionality reduction by the PCA or SVD process over. Next, I want to see that I want to see which columns gives like which batsman gives the consistency on that. Because
there also I need to cut off. Okay, I need to cut off all that things. So out of these unique batsman teams available, I need to reduce that consistency team. I've been picked out some list over there. And if DF of batsman is in consistency teams, then you put out. Otherwise, you leave for there. The same way the bowling team is also. So if all these columns are there in these columns, then you only put that column, that names. Otherwise, you leave that. Otherwise, you drop that. That's it. So after dropping that, we got that df dot shape is these many shape is we got over there. Then the next I was going to check that we have listed out few points like keeping only the consistency team. Next, removing the first 5 overs data in every match. Because I don't predict that before 5 overs, I don't predict that. I'll predict after the 5 overs and which position of that scores will be. So I'll remove this 5 overs, above 5 overs the data. So what do you do? Just simply df of that of overs greater than or equal to 5. Just we put that. So next thing is that I want to convert my date into a date time format itself. This is my format. I have converted that date time. So I got the date time format over there, guys. Okay, date time format is done. Next, I want to see certain relationships is been obtained by different columns only. If the correlation has been obtained by that 2 columns, then you use only 1 column. If you have high correlation like 90% above, then out of 2 columns, you use only 1 column. For that sake, I am finding this correlation. df dot corr is used for finding the correlation between all the columns. So one column with the other column, one column with the other, all the columns, one column with the other columns, it find out the correlation. Next, after getting all that correlation, I am just going to plot in the, what is this map called as, guys? Anyone tell that what is this map? Can anyone tell that what is this map? Yesterday we have seen this map. Right. Okay. This is an heat map, guys. Good. Okay, this is an heat map. Yesterday we have seen. We are plotting these heat maps. So as you see that this heat map, okay, as you see this this heat map over there. Okay, I am only seeing that correlation only for the runs and overs. Other than that, I didn't find any kind of correlation over there. Okay, that's it. We have just understand that over the overs and runs is the high correlation. Next, I need to go for data pre-processing techniques over there. So to pre-processing the techniques, because before loading the data to train and split, we are now converting that categorical columns into an, what is that columns? I'm just converting that categorical columns into an numerical columns itself. So after converting these categorical columns into it, so we have one technique called as one-hot encoding. One-hot encoding will do that. So it converts all the elements of the columns into and zeros and ones itself. All the elements are converted into zeros and ones by splitting the columns with the unique names. That's what it has been done, guys. So after splitting all that, now your data set is nowhere categorical itself. All that it has been object type itself. So all are numerical types. So now we are arranging all that in the order, particular order. If you are done, it's okay. If you're not done, it is okay, because to list out easily, I've just arranged that in the frame. Next, splitting the data into train and test set. Like now we are going to splitting this data like encoding a D of all that, and which is equal to 2016, all that splitting. Like all that splitting has been done. So years less than 2016, years less than 2016, now that has been training data. That has been training data. And years with greater than 2017 of that data is gone for the test data itself, because I need to split the data. Total we have 2008 to 2017 data is available to us. So 2008 to 2016, that 8 years data has been loaded out to the X-train, and the 1 year data is going for the testing purpose. Okay. So we are going to test that by X train and Y train over the process. And we are going to see that shape itself. As you can see that this much of the data has been sent to the X train and this much of the data has been sent to the testing itself, training and testing. Next one is model building. Next one is model building itself. So when you see that model building itself, we are going to apply model building is applying the model to the splitted data itself. Applying the model means algorithms. So we have applied a linear regression algorithm, guys. So we have seen that linear regression has been applied to that. And we got to see that all the three models has been applied. And next, this part is that we are going to predict. The function is that predict score. What basis you are going to predict? If the batting is equal to Chennai, then the temporary array will be taken down, comma, if a bowling team is these arrays, suppose, and your overs. This is one example, and these should be stored in the temporary arrays. And if this condition is available, if a bowling team is equal to Chennai, then all this temporary array should be stored in the temporary array. Otherwise, it should go into the loop and find that which it has been matching out. Certainly, it goes into that. And next, what is that? After getting this temporary arrays with that. Temporary arrays means nothing but if it is sunrises, then your encoding will be one it over there. That is been stored in these temporary arrays, plus all the data which you are giving out, like overs, runs, wickets, or should be stored in that temporary array also. And that temporary array should be converted into a NumPy array. How do we convert? np.array of taking that list of the temporary array, we will convert that. Now return, what is that prediction? Return integers of what model we are applying? Linear regression model dot predict. What is that predict of what is the temporary array which you are given at? Like you are giving overs equal to this much, runs equal to this much. All been taken down as a temporary array of the data. Now what is that? Now if you check for that, if you check, you are giving now that temporary array. Batting team equal to Chennai Super Kings. Okay, it goes back into that. If it is batting team is equal to Chennai Super Kings, then your temporary array first variable is 1. And next thing is that what? Your bowling team is equal to Rajasthan Royals. Then your Rajasthan Royals, where is that Rajasthan Royals? Okay, last but one is 1. Because the first is 1 and last but one should be your 1 for the temporary variable. And it should fill all the values plus all the values which are giving on should be in the list. Like what is the list? 9.1 comma 100 comma 2 comma 60 comma 0 all should be stored in another list, and this list will be sent down to predict of the linear regression model. Then you will get these kind of predictions over there. These are the values predicted over there, right? This is that data which we are running out. Okay, now this is values has been predicted over there, and you are going to find out that prediction values with the data itself. Okay, any queries you can ask me, guys. Any queries you can just ask related to these algorithms, all that which we are seeing. Any queries? I think almost all of you understand this data set. If you understand that, can you? No question paper. How do we use API keys? No questions. How do we use API keys? Yes, API keys are nothing but the token, guys. So it's used for the deployment of models for the global servers. Okay, it is used for these keys for the global servers, guys. Like suppose you want to connect your algorithm with the global server itself. Okay, like if any one of you can give the results or give the questions, and any one of can see the answers on that scale. That's what global on that scale. So where in that scale you can apply APIs over there. It's one kind of header parameters HTTP request to make the request to an API telling to guide over the. Okay, like this is one kind of sign up for account on that scale, like giving that link where you need to sign out and giving that kind of request for that. Okay, it's used for that developer mode. Okay, it's used for mainly for that developer mode itself. So where you give certain API, these are nothing but your requested responses, guys. So mainly for the request. What are a platform apart from Kaggle to get dataset? That's of UCA. I'll share you the link over there. Just give me a minute. So this is one source. So how can we perform this by own? Like how to get this code for practices? Right, guys. You need to initially study the dataset first itself. Then we get the dataset. Okay, you can get by different platforms like Kaggle itself, guys. Kaggle is the best platform to read out with the dataset, guys. First, initially register all the Kaggles. There are other events participated in the Kaggle also. Like you can perform all that Kaggle events also. So the thing is that initially you need to understand the data. That's the first thing is that. So where you understand as a data scientist or all the artificial intelligence engineer, all the ML engineers, they do is that they basically understand the data which is being sent by the data analyst people itself. Okay. So upon understanding the data, what kind of algorithms like they need to adopt that, they are going to see that. Okay. Can you please share the collab link in the chat? Okay. Yeah. No problem. These guys will share you the collab link in that. You can go through that collab link, guys. With the data set, I will share you that. No issues. Like, okay. Yeah, Amar. This is my end of my side.
Okay, sure. Thank you so much.
Right.
So
Yeah.
guys, day 1 and day 2 material is already there over LMS with collab link and dataset. So you can access that. And coming to the day 3 material, it will be there with dataset with IPYNP file by tomorrow. Okay.
Right.
Now, if you have any query or question for me, let me know in the chat box. One more. Yes.
Right, Amar. I am leaving that.
Yeah, sure. Thank
Right.
you.
Thank you, guys.
So guys, I already shared the attendance link multiple times, and for you, I'm sharing it once again in the chat box. So please mark your attendance and don't forget to share your feedback as well. Any query, any question, let me know. If all clear, just mention clear, sir. No any issue. We're enjoying the session. Sir, I attended the whole lecture. Arre baapre. It's too long text. Let me maximize my screen. Sir, I attended. अरे रुको जरा रुको. Just 2 minutes before, due to internet issue, I had a rejoin. Will it affect the attendance? No, Harshida. No need to worry. Because that's why is to join via your mobile net. That's why it is to affect. So we kept as a Google form to fill your attendance. So I have watched the first 2 classes on YouTube, but I didn't get the attendance on the particular days. As I saw those classes today on YouTube, after attending 3 classes, will I get the certificate or not? I have missed it. Yes, you will get. Yes. Enjoying the session. Clear, sir. Amazing. Sir, I missed the first lecture, so I'm going to receive the certificate. So, guys, coming to the certificate, 60% attendance is mandatory. Okay, so you can calculate on your own how many session you have to attend. Mark the attendance. But coming to the all the part, you can attend all the 5 days. Definitely, it will be a more beneficial for you as your future perspective. And one more announcement: those who miss that attendance or those who miss that session, don't worry, you have a recorded session with you. Okay, so you can go through that. Sorry, guys. No issue. Enjoy the session. Thank you. Amazing session. Even I didn't get the attendance. Vijay Lakshmi, from when you are joining the session? Can you please share it? Yes, I'm sharing every day. I'm informing 2-3 times. Yes or no, guys? I'm informing here to mark the attendance. We need the recorded session. Recorded sessions are already there over the LMS. When you will get the certificate. So on the last day, we'll explain that. Don't worry about that. So you can just focus on the session. Sir, where can we access the recording of the session? So Priya, over the LMS. So nice, amazing session. Thank you, Maya. Amazing sessions. All doubts are cleared. Thank you, Pritam. How many days this session continues? So this training program is for 10 hours and we're successfully done with the 6 hours. So 2 more days to go, Friday and Saturday. On Saturday will be the last day. Amazing session. Thank you so much. Thank you so much, guys. Today I'm getting such a wonderful response from your side. It's very good. Sir, hey sir, I attended classes, but I kept the attendance today. You have to mark your attendance on daily basis. Okay. Very helpful. YouTube channel is XLR Solutions. We have 2 YouTube channels, XLR Solutions and XLR. You can search that. Will I get a certificate? Yes, you will get if your attendance is more than 60%. The message in the chat box appears and disappears. That is why I guess guys are asking several times. It's not like that case Shaker, because few of the participants used to join a late, or else they are leaving and they're rejoining. It's not going anywhere. You can, if you are there from the first minute of the session, you can just scroll at upper side. All the attendance are there. Okay, Shekhar? XLR is the best. Thank you, Akansha. Akanksha. Okay. Enhancing knowledge session. All previous FDPs are available on YouTube. Yes, Jivna, it's not FDP, it's SDP. Student Development Program on Artificial Intelligence and Machine Learning. Let me check the comment over the YouTube as well. Guys, are you there? YouTube participants? Sir, I have joined on YouTube first day. Yes, on YouTube as well. If you check the live chat, I am already sharing the attendance link over there as well. And coming to the application on the LMS, the attendance is there also. Wonderful class, sir. Thank you so much, Suprita. Hi, sir. Yes, Roshni, tell me. Niharika. Sir, I did not give the attendance yesterday, but I attended, sir. First day, I filled the attendance list in Google Form and today. Okay, Kaushik. Sir, I did not give the attendance. You have to give how to access the LMS. Jivna, you can go through the day one recording. I clearly explain how to access the LMS. Even yesterday. So, what do you want to say? Can you guys see? Don't be like a WhatsApp chat. Hi, sir. Hello, sir. How are you? Okay, it's not works. Sir, I attended this session and I not received the attendance. What is the solution? You can type it down in the one message. Hi, sir. Hello. It is complicated to read me, right? You're with me? You're on my point? Very good session. Thank you. Already I have an account. So you can just set your password by that account and log in there. You will get. Now can I get the attendance for the attendance? Now can I get the attendance for the attendance? No, we are not able to share the past days attendance because no one is able to go in the past. We are also not able to go in the past, right? See, the attendance link is to close sharp at 9:30. So we're not able to share that. Thank you and sorry for that. Shreyash is saying how you mark the attendance for the attendance. What will have to do? Shreyash, it's your first day. Guys, if you're saying the present, I know that you are there, but see, there are 800, 900 plus participants. How I know that? By name. Hey, Harshita is there, Pritam is there, Akanksha is there. I don't know, no? So I'm sharing the attendance link. You have to mark. Ali Hassan, love from Karachi. Thank you. Sir, can I get the certificate? I can't give the attendance on second only, sir. Yes, Kaushik. I'm explaining 60%. So you can divide 5 by 4 into 100. You will get the percentage. Yesterday also attendance, but didn't feel. So Vijay Lakshmi, what is the issue with your attendance? Be like, you don't have idea about the. You have to mark the attendance. But if you attended the complete session, I used to inform and each and every day till the last minute. Guys, I already shared the attendance link. I'm sharing my attendance link once again in the chat box. It's my regular words. Sir, today's attendance. Today's I'm going to share. Don't worry. See, hey, take it the today's attendance link. Mark it, please don't forget. Yeah, I know. See, in the first 2 hours, you are gaining the knowledge. First priority is knowledge, your skills. Okay, but somewhere to show your achievement over the LinkedIn, over your resume in your college, right? You need that certificate. So I'm explaining every day. Yes, guys, we are done with the day. If you don't have any query or question, we'll meet you on tomorrow at same time. So you can leave for the day, I think, and it's time to wind up for the day. So thank you so much, all of you, for joining the session. We'll meet you on tomorrow. Bye bye. Take care of